Okay, guys, I'm continuing my attempt here at recording videos using my new device. I've got a handy pin here for for all of our enjoyment, and we're going to go ahead and solve number one. I imagine you've had a chance to read through it. If you haven't had a chance to read through it, go ahead and do that now. Um, Basically, what we're doing is we're trying to find this value x right here, right? And it's really a lot easier in trigonometry to be using right triangles. So if for some reason we can't get a right triangle or can't get this side in a right triangle, maybe we can use other right triangles to help us. And lo and behold, in this problem, we've got two different ones, right? We've got this big right triangle here, right? That big one. And we've got, I see an application here. I'm learning as we go. You'll kind of see how I learn technology here. You got to play around with things, right? Um, and I'm going to show you there's a right triangle right here. Oh, look at that. Ink to shape. And there's another right triangle. Let me go right here. Let me outline that one. That one's a little bit harder to see. Maybe I could, excuse me, maybe I could highlight it and see how that one goes. I didn't like that ink to shape. Use the green one. That one shows up pretty well there. Except it didn't come out to be a right triangle, did it? Anyway, you can see this right triangle here. And the other one that we dialed in, which was the whole one. And again, it kind of disappeared on us because of this, the way this is working. So we're looking at those two triangles. Now, in the bigger triangle, we do have a right angle because we got a right triangle in both of them. And so if I were to just redraw that big right triangle to help us out, okay, you would see you'd have a right angle here. And trying to, I guess I can't move that too easily. Not the way I want. Anyway, you've got that right triangle, and you've got a 40-degree angle there. You've got a right angle, and you know that this side is 87 feet. You know that this side up here, we haven't given it a name. Let me call that Y, okay? And if we use that big triangle and we find that Y value, and let's say I go back to my, go back to a green color here. This triangle right here, if I find this side is Z, let's say right here, right? And I can take Y minus Z to find X. So let's go ahead and find Y. Now Y is going to be, this is the opposite side, right? And this is the adjacent side of angle that's 40 degrees. And I found this pencil is a little bit more precise. Okay, so now opposite and adjacent. We want the opposite. We know the adjacent. We have the angle associated with those sides. And remember, SOHCAHTOA, okay, helps us to actually calculate certain things, especially in right triangles. Opposite and adjacent, that is tangent. We're going to use the tangent of 40 degrees in this triangle is equal to the opposite, which is Y, all over 87. Okay. I don't know what these stray marks are here. Okay. Now, how do I solve for Y? I have Y divided by a number equals some other number. This is just some number. We don't care about what it is right now. Tangent of 40. We have y divided by some number equals some other number. How do I solve for y? Simply multiply by that number it's being divided by. Okay. So y equals whatever that is. I'll call that answer. Okay. Not concerned with what that is because that's not my final answer. Remember, I have to take y, which is that value, and subtract z, which is this value here. So let's look at that smaller triangle on the bottom. Okay. We've got that angle that was 25 degrees in there. Oop, boy. I gotta erase that. Yeah, now look at me. Okay. Got 25 degrees in here. I've got my value z that I labeled, and I got 87 that was given. This is another tangent, right? Because this is opposite, and this is adjacent. And we know, again, SOHCAHTOA, the tangent of 25 degrees is going to be equal to opposite, which is z all over 87. Same algebra as what we did up here, right? The exact same algebra that we did up here. Okay, we're going to follow here. We got our variable divided by a number equals some other number. All we got to do is multiply both sides by 87. Okay, that's going to give me z. Okay, now I don't really care what z is. I want to find x, which is my z minus y. Remember from this diagram, y was this, z was this, x was this. So x is z minus y. So this is my z. This was my y up here, right? So I'm going to take z minus y to get x. So I don't care what z is. Z is 87 tangent 25 degrees. And I'm going to take that and subtract it from the answer I got up here, right? So x is 87 tangent 25 minus my answer from before, right? Okay, so go ahead and plug that into my calculator. And I get, let's see. So 87 tangent 40 was 87 tangent 40 is about 73. Okay, and then that's my answer now in my calculator. Now I'm going to take that, which is y. Oops, I did the wrong thing here, right? It's got to be the answer minus, x is the answer minus this 87 tangent 25. In essence, we're taking 87 tangent 40 minus 87 tangent 25. Okay. Excuse my writing here. Still getting used to this pen. 87 tangent 40 minus 87 tangent 25. And it's about 32 point something, 0.4. And we're rounding to the nearest foot. Okay. So this is approximately equal to 32 feet. That's my final answer for x. Okay.